Out to Chase Berry for three. Rebound by Peyton Crispin. He's going to put it back. And they got it! The Lakers hit a three.
Welcome back again. Steve LaPorte, home of your SWOCC Lakers.
Can't get the shot to go. The Lakers win the ball game. Go! Lakers win! Lakers win in overtime. 108-106.
Do you like to work with metal, fire, electricity? Would you like to make money doing it? At Southwestern, we can help make your dream a reality. With our degree and certificate programs in welding, you'll be prepared for a career in the welding and fabrication industry in as little as a year. Check out our website and let Southwestern spark your career in welding today.
Southwestern Oregon Community College gave me the opportunity for a new career doing something I love. I'm Amber Yardley, and 3 years ago, I knew I needed to make a career change for myself and my family. With the support of staff, my academic advisor, and the instructors at SWOCC, I now have a dream job and the confidence to continue my education. Contact Southwestern Oregon Community College and start the journey to your new career today.
This is Southwestern's Dental Assisting Program. In just one short year, you could be a dental assistant. Sign up now for your one-year dental assisting certification.
Hey, shameless self-promotion. Hey, Dallas, one thing. Is this mic hot or no? Do you want me to turn that on? Okay. So, ladies and gentlemen, how are you all doing tonight? Fantastic. Just a couple of different bookkeeping, housekeeping kind of things. My day job here, and I swore last night that I would not do this, but since I'm in a different mode tonight, my name's Ron Metzger. I'm the geology department here at SWOCC for almost the last quarter century, which is a little bit scary. But one of the things that I do in my day job is host something called the Geology Lecture Series. So if you would like to be a minion, if you would like to take some of these lovely posters for the November 8th talk with you this evening, I would be pleased to have you take them various places along the coast that post posters. That would be awesome. I need a helper with extra hands. Also have the entire year schedule, so feel free to take those and throw those on your refrigerator as well. isn't the geology lecture series, but there are these lovely green sheets out there. If you didn't sign your name on the way in, if you would be so kind as to sign it on the way out. Part of the thing is that the event is free, and so bringing free stuff to you, whether it's the geology lecture series or the series of presentations / symposium on offshore wind energy today, to make those happen for free, sometimes you got to justify existence. So I'd appreciate if you take a minute to do that. Not the official geology lecture series, but I figured that if you're here tonight, you probably are a STEM supporter and appreciate science, engineering, technology. So if you do, I didn't leave it out there, but I have this lovely little glass jar that says Donations Geology Lecture Series. You're welcome to put $1, a quarter, $100, whatever you would like into it. It helps continue to bring science to the community. And most of you caught the one-page Michael Mitton handout as well. If you didn't, and there's some available on the way out, you're welcome to grab those as well. If there are none left in one person, I will auction that to the highest bidder. Okay, switching gears now to tonight. About just under a month ago, somebody came to my office during in-service, which those of you that are in education know in-service is the most wonderful time of the year. And I'm sort of one of those people that tries to put stuff together way ahead of time. So you will notice that the geology lecture series sheet that I gave you includes a talk in May. Okay, that's way down the road. And so the suggestion was to throw together this wind energy series of presentations and present it in less than 1 month. Well, the way mind works is, and so we talked about it a little bit, and one of the things that impressed me is that I know that it's a potentially contentious issue, but it also was something that was presented to me with a number of different viewpoints. And so that was something that I thought was important. As an educator at a college out here, and the only college in the neighborhood outside of OIMB, the satellite, it was the kind of thing that I also thought as an educator that if the conversation's gonna happen, that this is also the place that it should happen. And so we worked, a number of us, very diligently in order to pull this together in very short time. And a few of you I recognize from last night. So you also know that I had the hall booked last night, which I had said was actually beneficial for this. Our keynote, Michael Mitton from Portland, this was in the window of time that fit for him. And since I had the hall Friday, I was pretty confident that I could get the hall Saturday, dependent on Dallas, our IT person, which worked out since we're all here today. So this wide-ranging series of presentations is going to cover a number of different aspects of offshore wind energy. We'll have a little bit on renewable energy and sustainability with Michael Mitton, that I mentioned. We'll have some coverage of engineering, science, and construction of wind energy with Dennis Beethan, and regional energy infrastructures. I said last night, it's been one of those weeks. It's also apparently continuing into Saturday. Regional energy infrastructure and markets with our local Shannon Souza, potential economic impact on the South Coast with SCDC Director Sam Baugh, and also some community engagement with Sam Schwarz. And following that, probably the most important part is a question and answer session. So without further ado, I'd like to introduce this evening's keynote speaker, which is Michael Beethan, and he sees climate disruption as a growing global threat, but a unique opportunity for coastal Oregon. He's currently retired, but he was a founder of a CEO of a biotech company. Over the past 20 years, he's focused on climate-related issues, including science, public policy, and technology solutions. He's researched and compiled an economic development scenario for Coos Bay because he believes it can bring sustainable economic benefits to the region and help Oregon become a leader in this industry of the future. So thank you all for making time on your Saturday, as well as our series of presenters. It's my pleasure to introduce to you this evening Michael Mitton.
Thank you very much, Ron, and it's a great pleasure to be here this evening. I do want to express my appreciation to Professor Ron Metzger and the Southwestern Oregon Community College for putting this event on. We have an exciting agenda tonight, so I'm going to jump right into it. A major transformation is taking place on a global scale. Changing from fossil fuels to clean energy is clearly a monumental task. But it is also an enormous economic opportunity that is already producing a number of sustainable jobs in our country and many around the world. The South Coast can participate in this new industry and diversify its economy in the process. To me, that's a win-win. The coast of Oregon has a tremendous, oh, I gotta do this, all right. Excuse me, I'm lost here. There we go. The coast of Oregon has a tremendous natural resource that is now high in demand. An offshore zone about 300 miles long, straddling the Oregon-California border, is a sweet spot with the energy density, the best energy density along the entire west coast of the United States. Coos Bay is the largest deep draft coastal harbor from San Francisco to Puget Sound. It's well suited to play a major role in the development of this unique and vital natural resource. A year ago, California passed a law requiring that all its electricity be 100% carbon-free by 2045. Offshore wind will play a major role in meeting that demand for reasons I will outline. This opportunity to diversify the economy of the South Coast is driven by increasing demand for renewables. So let's take a look at some reasons why that is happening. I'll start by summarizing why clean, renewable energy is growing so fast here and around the world. The continued use of fossil fuels is unsustainable. So that's reason number one. We have no choice. That's usually a pretty good reason to do something, but it gets even better. Costs have dropped so dramatically that solar and wind are now cheaper than gas and coal for generating electricity. Some of us may have noticed that the wind isn't always blowing and the sun isn't always shining. However, there's good news about that too. A wide range of new technologies is helping to mitigate this intermittency issue. It's an important part of that are battery costs, which have dropped dramatically and show no sign of leveling off yet. The accelerating pace of change towards clean energy was highlighted this month in Oregon with a press release from PacifiCorp, the Portland-based utility that serves nearly 2 million customers in the western U.S., said that it will shut down 16 of its 24 coal plants by 2030 and replace them with heavy investments in wind and solar. Finally, we're seeing a definite trend where investors around the world are divesting their fossil fuel-related assets and reinvesting that money in renewables. These are the main drivers fueling the fast rise of clean energy and the sustainable jobs that will come with them. Some people think eliminating fossil fuels is too difficult and will take too long. However, there are many places around the world that are already making good progress towards that important goal. I'll cite just a few examples. In the UK, 10 years ago, coal and natural gas generated more than 70% of their power. This year, renewables are generating more than 50% of its electricity. The UK has 66 million people and is the 6th largest economy in the world. Denmark, by 2017, this country was already getting more than half its electricity from wind and solar. 43% of its electricity consumption was from wind alone. That set a world record. The country aims to be 100% fossil fuel by 2050. Uruguay, less than 10 years ago, they were getting 40% of their power from renewables. Now it's 100% after heavy investments in wind and solar. Morocco is now connecting the largest solar plant in the world to their grid. Together with wind and hydro, this mega project is expected to provide half of Morocco's electricity by 2020. Sweden is going to completely eliminate they're planning to completely eliminate fossil fuels by 2040. To do that, the country has ramped up investments in solar, wind, energy storage, smart grids, clean transport, the whole package. This slide's about Scotland, shows what they're doing. They set broke their monthly record for last October, got up to 98% off of renewables. 12 U.S. states have already laws on the books to get to 100% clean energy, and many others are in the process of passing similar legislation. So far, we've covered the basic elements of this opportunity. We also saw how others have started to take advantage of it. Now let's see how this industry of the future can diversify the economy of the South Coast and create sustainable jobs. As we know, the devil's always in the details. Let's start by looking where wind energy is today. Windmills have been around for centuries, but it wasn't until the 90s that utility-scale wind farms were constructed to generate electricity. Offshore wind is even newer still. One acronym I need to explain is gigawatts. That's 1 million kilowatts. It takes roughly 2 typical coal plants to make 1 gigawatt of capacity. A gigawatt's roughly 650,000 homes as another means of measurement. The industry, the offshore wind industry grew from only 2 gigawatts to over 500 in 20 years. It's probably going to double in the next 6 years. Offshore wind is less than 20 years old and has been limited to shallow waters where the structures can stand on the seafloor. Floating offshore wind technology has recently been developed to access the deep waters where the stronger and more consistent winds produce significantly better economics. Globally, offshore wind capacity now tops 22 gigawatts. That's a 10-fold increase over the past decade. 20% of that was installed in 2018 alone. Europe's the world leader. They have 105 offshore wind farms. UK and Germany alone employ 50,000 to build and support these offshore wind farms. Or, I'm sorry, just the offshore wind farms in their countries. Not all 105 are in those 2 countries. The U.S. has only 1 small offshore wind farm in Rhode Island, but a number of projects are under construction on the East Coast. Harnessing America's offshore wind resource presents an enormous opportunity to create tens of thousands of good-paying jobs, revitalize coastal communities, deliver large amounts of clean, renewable energy to the country's biggest population centers. Before seeing how we could make that happen here in Coos Bay, let's take a look at one of the key drivers of this industry, the rapidly falling costs of wind versus the costs of fossil fuels. Energy experts at Bloomberg have said that not only is renewable energy cheaper than building a new gas or coal plant, but it will soon be cheaper than continuing to use existing coal and gas plants. This is an important economic tipping point. It means that it would save money to shut down existing coal-fired plants and build new, build new clean energy plants from scratch. And that's exactly what we were seeing in the Pacific Core announcement made recently. They plan to install 7 gigawatts of wind and solar by 2025 and retire 16 of their 24 operating coal plants by 2030. And this is being done by many other utilities, a growing number of utilities in this country. After almost a century of development, coal and gas are at the top of their technology curve, and further cost improvements are not expected. On the other hand, wind is on the steep part of its technology curve, and costs are expected to continue declining. Offshore wind is newer than land-based wind, so its costs are higher. But it is experiencing rapid price declines, as seen in this slide about a new project in the UK. This one shows a 31% drop in just 2 years. The math on offshore wind turbines is pretty simple. Bigger is better. Europe has a 20-year head start on the U.S. and now has, as I mentioned, 105 offshore wind farms in operation. The good news is that they have made significant advances in technology, which has driven the cost down. That's a big benefit for the United States. We can see the same costs here when we get to scale. Currently, there is only one small wind farm connected to the grid. Vineyard, the second one, is under construction in Massachusetts and was priced 75% lower than the Block Island one, the first one, was just a couple of years earlier. While offshore still has to catch up with onshore wind with regard to costs, it does have other advantages. Stronger wind has a bigger effect than you might expect. For example, a turbine operating in winds of 16 miles an hour will produce 50% more electricity than the same turbine operating at 14 miles an hour. More consistent winds also have a big effect by helping to smooth the daily and seasonal fluctuations in power output produced by onshore wind and solar. On the West Coast, offshore winds typically grow stronger after sunset and also get stronger in the winter. This complements the period when solar drops off. As I said, math on turbines is pretty simple. Bigger is better. Longer blades capture more wind. It's an ideal way to boost efficiency. Size is limited on land-based turbines due to height restrictions. The main components for larger turbines, larger offshore turbines, can only be transported by sea. They're just too big for rail and highways. After decades of development, many of the best sites for land-based wind energy have been taken. Real estate prices and land use restrictions are also shrinking the remaining supply. All this favors offshore development. Floating foundations are the latest development in offshore. They will provide access to the energy-rich wind resources that lay deeper offshore like most of the western United States. High Wind Scotland is significant for several reasons. It demonstrates floating designs can withstand the rough conditions found here on the West Coast and still produce the high output expected by designers. We've now looked at developments elsewhere. Let's focus on the West Coast and Coos Bay. NREL, which is the National Renewable Energy Lab, is the renewable, this is their map, and the wind strength, it depicts the wind strength accessible waters offshore. The total amount of offshore energy available in the U.S. is at least twice the total generating capacity of the entire country. An offshore zone 300 miles long, straddling the Oregon-California border, is the sweet spot with the highest energy density. Coos Bay, as we said, is the ideally suited, being a largest deep draft coastal harbor between San Francisco and Puget Sound. So it's very well suited to play a major role in the development of this unique and vital natural resource. Offshore area to the south, near San Francisco and Los Angeles, have less favorable wind conditions and more marine traffic. That's not good for offshore wind farms. Also, the Navy has blocked large areas from wind farm development in Southern California. Until recently, offshore wind simply didn't make economic sense along the West Coast. The main reasons were deep water, rough weather, high costs, and uncertain demand. All that has changed dramatically. Costs have seen steep declines. The technology has demonstrated it can handle the rough weather, and most importantly, a large new market has materialized near Coos Bay. There are a number of factors that favor offshore wind to provide a big portion of the renewable power that California will need to meet its mandate. Last year, Senate Bill 100 became law, requiring that all California's electricity be 100% carbon-free by 2045. California's economy is the 5th largest in the world, and it consumes 8% of the U.S. electricity. California's aggressive goal to electrify its transportation will only further increase this demand. There's a growing list of companies like Amazon that are now buying their renewable energy directly from the developers. Amazon just ordered 100,000 electric delivery vans. We're going to see them on the streets starting next year. They're one of the many companies that are committed to be 100%. For example, Amazon's goal is by 2030. Apple, a number of other companies are already there. Faced with this rapidly growing demand for renewables, why can't California just continue to build solar and wind farms on their land? Well, the short answer, we've already said it, is the prime sites are already taken, the growing populations are driving up high real estate costs, and there's an increasing number of land use restrictions. And of course, the ultimate driver for California or anywhere else is economics. A recent study by analysts at E3 Environment, Energy, and Economics found that 9 gigawatts of offshore wind farms could save California ratepayers $2 billion by 2040. This adds up to a huge export market for Oregon's offshore wind energy. Not surprisingly, all this has attracted a large group of offshore wind developers to the energy-rich resource that straddles the Oregon-California border. One company has already submitted an application to BOEM, that's the federal agency that manages the offshore leases, for a floating wind farm 20 miles, I think it's 20 miles off the coast of, it could be 30, off the coast of Eureka. It should be noted that developers will face technology, transmission, permitting, financing hurdles before we'll see the first wind farm in operation there. The impending development of offshore sites in Northern California presents a window of opportunity for the Port of Coos Bay. If a concerted effort is made to secure the assembly, construction, operations, maintenance, activities for these projects, it will provide hundreds, possibly even thousands of sustainable family wage jobs. The big question is, which seaport will developers decide offers the most cost-efficient base for their operations? Coos Bay has a lot to offer. As you can see from the map, the sweet spot for the entire coast starts at Coos Bay and runs 300 miles south. Beyond that point, as I've already said, California's got less wind, and there are large restricted military areas, and they've got a lot more marine traffic going in and out of those ports. Obviously, that's less favorable for wind farms. North of Coos Bay has good wind and relatively fewer navigation issues, continuing all the way to the Canadian border. This makes Coos Bay the logical hub for the West Coast, but efforts to attract that business need to start now before the final decisions are made. Developers have already committed to build one wind farm near Eureka. It will be the first on the West Coast. Companies are planning additional offshore developments in that area. Encouraging this first group of companies to conduct their construction, operations, maintenance, all their activities here in Coos Bay is an essential part of a strategy to become the hub for this industry. It will enable the supply chain to get started, and it will to get started and allow it to start growing in and around the port. This is the key to bringing the jobs to Coos Bay. If successful, this will lead to investments in docks and other infrastructure around the port. Once that happens, there will be little incentive to duplicate it anywhere nearby. This is primarily due to the ease of transporting floating turbines with an ocean tow vessel. A growing supply chain, together with some dock and infrastructure investments, will provide a significant advantage to attracting more business to the port as time goes on. Currently, no developers have begun the long-term process of planning offshore farms in Oregon. But given the wind resources that are here, they will come. Ironically, developing nearby California waters first actually gives Coos Bay a distinct advantage. It allows the port to get in the industry early, which is vital to building a supply chain. At the same time, it can avoid the delay, distraction of building transmission lines to the grid and finding buyers for the power. Ultimately, these issues will need to be addressed once development starts in Oregon. But for right now, avoiding them is a plus. Port facilities have significant cost impact for wind developers because work is all completed in the port before the turbines are towed offshore. Additional cost of a longer tow has a minimal impact on the total costs of a project. In addition to being centrally located, Coos Bay has other advantages. Its port facilities are superior to other nearby choices like Humboldt Bay. It has land with appropriate load-bearing characteristics for staging and assembly of the heavy components. It has room for expansion. Its existing grid connection options are better, but will need upgrading as the industry grows. Oregon is already home to major international offshore wind companies such as Avangrid, Vestas, EDPR's here, and there are others. Coos Bay has two well-positioned companies that could provide the key to starting the supply chain. Those companies are Sauce Brothers for ocean towing and DB Western for construction of the floats. Workforce training is also critical for this new industry, and this campus at Southwest Oregon Community College could play an important role in that. These initial seeds can be the start of a growing supply chain, which is the key to getting the jobs to locate here. Almost all activities associated with offshore are completed in the port. This is where the jobs are. Major components arrive by sea. They're too big to come any other way. They're assembled and built in the port. The supply chain grows in the port. Parts are increasingly fabricated in the port. This is likely to start with the building of the floats for the turbines. We'll hear more about that, I think, from the next speaker. This, by the way, is the new GE, the biggest, most efficient wind turbine in the world. The tower is 850 feet tall, and each blade is 350 feet. The finished units are then towed out to sea and anchored. Operations and maintenance vessels and crews are based in the port. Establishing Coos Bay as a base for offshore wind on the West Coast could create hundreds and ultimately thousands of sustainable family wage jobs across a wide range of sectors. In a minute, we will review a study completed by NREL for the West Coast. But first, let's take a look at how offshore wind has already created jobs elsewhere. Europe is the world's leader, as I mentioned, 105 offshore wind farms in operation for decades. The two biggest are UK and Germany. UK has the most offshore capacity and currently employs 20,570. Their government has committed to expand capacity from 9, which they're at now, to 30 gigawatts by 2030. As you can see, the politicians are promising another 70,000 jobs with that expansion. Germany currently employs 27,100 in their offshore industry. There is currently only one offshore wind farm in the U.S. However, we now have 25 gigawatts in the pipeline, representing almost a 1,000-fold increase. Most of these projects are on the East Coast, where the states there have made significant commitments to offshore wind. These states have completed many studies of the potential employment impact offshore wind will have. Offshore wind jobs in all three phases of development: planning, construction, operations, and maintenance. These include engineers, site managers, longshoremen, port service workers, shipyard workers, water transportation workers, many others. Employment studies add up. The employment studies that were done for these projects add up to tens of thousands of jobs. However, there are some differences between the East Coast and the West Coast, so let's look at the West Coast. The UC Berkeley NREL study was done as part of their workforce impacts assessment for California. A similar study has not yet been commissioned for Oregon. However, the most valuable part of the wind resource is right on the Oregon border. Therefore, this study, I think, can serve as a good measure of the workforce impact we can expect if Coos Bay is successful in establishing itself as a major hub for the Pacific Coast. The slide assumes a 16 gigawatt build-out of wind farms. The study also includes a lower case scenario of only 10 gigawatts. So this is the high case, 4,300 sustainable O&M jobs, 13,600 construction jobs. The lower case scenario of 10 gigawatts, it reduces the numbers to 2,200 and 5,800 respectively. The study did not address this, but I'm going to go out on a limb and say that I think the construction jobs may continue past 2050. And the reason I think that is because wind farms have a habit of repowering as new and better technologies become available, more cost efficient, whatever. So they're doing that right now at a big one just along the Oregon border in Washington, a big repowering job. Repowering means they take the turbine and blades off and put a new one on. I think they usually use the same tower, maybe they don't. I should mention that a Department of Labor statistic shows wind turbine technician as the fastest growing job in the U.S. Okay, almost done here. Offshore wind ventures must survive a rigorous environmental reviews after they secure federal leases and before they can be granted construction permits. They also have to attain a wide range of additional state and local authorizations. It's a lengthy process that can take a decade and involve dozens of agencies. There are many points where any stakeholder can express a concern and pause the process. The lead agency is BOEM, the department, part of the Department of Interior. It stands for Bureau of Ocean Energy Management. Offshore wind farms are generally installed in federal waters, but connecting to the grid and other activities in the port are under state and local jurisdictions. BOEM's first step is to form a task force consisting of all the agencies. California did that several years ago. Oregon just started last month. Well, I don't think it's worth talking about the different stages of the BOEM process. That's the bottom line is, until construction starts, all stakeholders are heard. So here's the summary. And these are the main points. We have to change. The world has to change to renewables, and wind is a big part of doing that. The most valuable section of that natural resource on the West Coast lies right at our doorstep. A big new market has just materialized, and it's right next door. Coos Bay is an ideal base for this industry, but other possibilities exist. An effort needs to be made to convince companies to locate here before they go elsewhere. If successful, thousands of good-paying jobs will result. Success will also result in diversifying the economy of the South Coast and setting it on a path to a sustainable future. Offshore wind is a unique natural resource that's less subject to pricing and other pressures from other regions. I like this quote, so I put it in there. It's from legendary hockey legend Wayne Gretzky, and I think it applies to a lot of things, but it particularly applies to many big business decisions, especially these with long lead times. Clean energy is coming, that's a certainty. So the only question is not if offshore wind will be built on the West Coast. The questions are when, where, how, and who will get the jobs. These are sustainable, good-paying jobs, and it's unlikely they will just fall in our lap. Other ports will want them too. Coos Bay offers some distinct advantages to this industry, but it will take a coordinated effort to encourage them to base their operations here. Finally, it's important to recognize that offshore wind will not exclude potential jobs that might exist in other industries, past or future. It just adds to the employment opportunities available. Thanks.
Thank you, Michael. Really good. You were only off by about 1 minute, so that's a bonus. And I'll give you props for the great one quote, because that's the first time I've seen a hockey reference here, and I won't drop the mic. So our second speaker tonight is Dennis Beetham, and he's CEO of DB Western and has over 50 years of experience in the fields of chemical, mechanical, nuclear, and electrical engineering. He's been involved in wind energy resource and development for the last 20 years. His first venture was the development of a vertical axis wind turbine technology for the DOE. In 2015, DB Western submitted a proposal to Principal Power Incorporated to fabricate, construct, and launch the Principal Power Wind Float Pacific Demonstration Project from Coos Bay. Most recently, Dennis has been engaged with a Spanish university to improve the engineering design for a U.S. West Coast spar buoy system for larger turbines coming onto the market. He maintains a strong belief in the future of Oregon and California offshore wind energy development, and it is this drive that keeps Dennis striving to improve the technology of floating offshore wind systems. Dennis Beetham.
Thank you, Ron. Thank you, Michael. You gave my whole speech, Ron. I'm just first time learning this thing, so I'm going to DB Western, we've been here for 45 years. We've done around 80 projects around the world, in every continent. We've built most of them here. Some of them we've just provided the technology and drawings. We are a technical company. That's where our revenues really come in. We also fabricate, and we're general contractors, and we've built things all over the world. But our main our main position in the world is technology. We're recognized for having 5 of the leading world technologies in one of the industrial world, the chemical engineering world. So I'll just start. I'm going to show you the same chart that Michael just showed you, but for a different reason. There's a big difference between the East Coast and, quite frankly, most of the world. Most of the turbines that are being installed are in 200 feet of water or less, and they're mostly jacketed or monopiled and fixed to the bottom of the ocean floor. We have a very unique situation in the world, and that is we don't have a continental shelf. We have very little of that 200 feet and less. In fact, if you look at that little, over on the left side, the west coast, you'll see a little band that comes down the coastline. That's 50 miles. I'm going to show you a slide later on that gets a little more detail. But the important thing is that Humboldt Bay right now is the epicenter and which Coos Bay is going to compete against. If you look at that dark red, a lot of the developers are talking Humboldt Bay. In fact, I'll show you a slide which DOE recognizes 2 places, Humboldt Bay and a little port down there, Port Waiwina. I'm not sure I'm pronouncing that right, but it's north of San Diego. It doesn't recognize Coos Bay. I think that's mainly about California wind energy. Oregon has not shown any real focus on offshore wind energy. A lot of talk, but no focus. California is totally focused on it now. They even passed a law that they're going to do it. So Coos Bay is going to have to fight its way in. I'd like to think that we're going to be part of that fight. This will give you a perspective. So I'm going to give you basically a 10,000 foot about wind from an engineering perspective. Then I'm going to zoom it down to 100 feet for Coos Bay. Here's DOE's representative of every state in the United States that has offshore wind, even the Great Lakes and Hawaii. If you'll notice here, I guess I can point this finger at this thing. That doesn't work, Ron. Okay, the finger doesn't work. That's all right. Notice Oregon and California. Or you have to hold it down. What do you do? Oh, there it is. Okay, I see. Oh, forget it. Please notice Oregon, California. If you notice something, it's all red. That doesn't mean we're not a red state, by the way. But that means that all of our offshore ocean is less than 200 feet, but is more than 200 feet, but it's less than 1,000 meters or 3,280 feet. Well, I'm going to show you in a little bit what that really means. That means you can't mount anything to the ocean floor. The little blue down there means we might have a few spots we can mount to the ocean floor, and yet the developers aren't going to want to do that because if we have a little earthquake, that area is going to liquefy, and all those nice towers are going to go over, and they're not going to invest in that kind of situation. So we're stuck with floating units. We'll be the first place in the world that's stuck with floating units, and that's what I'm going to get to. Michael covered this pretty good. I want to cover a little bit more. Here's a chart that we made, a table, and I want you to, this will address some of the economics that Michael was talking about. You see, I won't pay attention to Washington. They're to our neighbor, and they have the most renewable energy, quite frankly, of any state in the United States. That's because they have British hydro coming down from Canada to mix in with Bonneville. And so if you'll notice Washington, they have a very high percentage of renewable. Oregon has a pretty high percentage as well. We're very fortunate because we live off that same BC hydro Bonneville grid. And we have We have some wind turbines on the Columbia River Gorge, and we have some solar, but that's very small. You can see the renewables down there in Oregon, 19. That's pretty small compared to hydro of 103. Now, I want to show you something that I think Oregon should be thinking about. Look at California, the sum total of gasoline and diesel fuel. Your sum total of 504 and 1. Look at that as the goal. California's got a goal of being all electric. They want to have all electric cars and all the electric trucks, and I think Oregon would too. But guess what? Oregon can reach that goal because if you look at the sum total of their, it's 83, and everything is in terawatt hours per year. Now, you'll hear about gigawatts and everything else, but terawatt hours per year is the average power that renewables will put out that would compare with a nuclear plant, with a fossil fuel plant, because a lot of renewables don't operate all the time. So this is the way you normalize. So I've normalized all the diesel and fossil fuels for cars and so forth. And California has not a prayer with their offshore, because they can only generate 400 terawatts. Oregon can generate 200 terawatt hours per year. We can actually ship, after we get rid of all of our gasoline cars and all of our diesel trucks, we have 60 terawatt hours per year left over to market to California. And I actually put a number on that at 5 cents a kilowatt. That's $28 billion a year. Now that's quite a revenue for Oregon potential. Of course, the developers are going to want the lion's share of that. And of course, somebody's going to tax those developers. So Oregon does pretty good in that department. So that's the main purpose here, to show you that in Oregon, we have an opportunity, and I don't see another opportunity except, some kind of wonderful nuclear program comes along, that we can generate the kind of electricity that everybody has a dream and a goal of getting rid of gasoline cars and gasoline trucks. And by the way, even that 5 terawatt hour per year coal. So that's the purpose for that table. And this table, this comes from, I want you to notice something. I wish I could point at it. I want to run up there and put my finger on it, but I can't. Look at where it says construction ports. Now this is Department of Energy, NREL. This is what's going out to the developers of the world. You want to see where you're going to build these things at, with the most likely ports? Well, there's two. One is called Fields Landing. If you know Humboldt Bay, that's in Humboldt Bay. And the other one is Port Huena down by San Diego. Those are the only two places that the DOE thinks are likely candidate to build these wind turbines for California. You'll notice there's nothing about Coos Bay here. That's the only purpose for this table. Now I'm going to show you some detail. This is Oregon. Can you all hear me all right? I tend to speak loudly. I don't want to. Is it okay? Okay. So you'll see there's a dotted line down there. That's a 12-mile. That's the federal state line that basically the state of Oregon claims ownership. Anything past that, out to the 200-mile, the federal government says that's an economic zone. In other words, we can use it. One of those things, you either use it or you lose it. So the only way you can develop out there, look at the blue. That's all above 1,000 meters. What DOE now says, that's not valuable real estate because the technology is not there yet. Well, I'm here to tell you that I think that it's potential that there is there. In fact, I'm going to show you a movie here at the very end. Well, here. Now, this will give you a good example of the Pacific, which is Oregon, California, and Washington. Very little, but is realizable. The little blue down here, that's what Department of Energy and NREL says Oregon can utilize. And that's mainly because it's more than 1,000 meters or 3,280 feet. And a lot of that is because you have to anchor these things or they'll just float off to Japan. You just have to anchor them down, and also because you need that stability in the ocean. There's a lot of wave action. I know Sauce knows about that stuff. You have to basically make sure these things are tied down and their yaw rate, etc., because if you yaw more than 5 degrees, you lose about 25% of your power. So it's not the fact that it can yaw, it's just the fact that it's the efficiency of the turbines. Okay, there's just a good example. We're working with GE now. We have an NDA with Siemens. Siemens has probably about 65% of all the turbines in the world. They are the 800-pound gorilla, as we say. GE pretty much fell asleep. Now they woke up, and thank God for that. GE is a very capable company, and they saw that everybody was running away from it, and they now see the huge potential of offshore, and they're into it big time. 853 feet, give you some idea. It's kind of fun to see that. By the way, the blade diameters is 750 feet. That's from one tip to the other. I mean, that's the circle. It's higher than the tower is. And oh, by the way, it's 65% is what I call the terawatt hour per year. That's the average. That's what you will achieve on a day by day, 365 days a year. To compare that, solar gets about 12%. In fact, right now, California is mandated. California grid cannot put any more solar on the grid. It's got such a peaking rate during the 4-hour period of solar's maximum energy, they can't put any more on the grid. The grid has got to function with a balance. It can't have just solar coming in at 12% of the time and occupy all the grid. You balance that grid, and Oregon and Washington are very lucky because we have 2 natural gas power plants, which Bonneville will tell you, do the peaking load. If you don't have natural gas right now, we probably won't have a grid. So I'm here to say, I'm an engineer, folks. I'm not politically correct. So if I offended you by talking about natural gas, I'm sorry. But in fact, you have to have natural gas if you're going to have a renewable grid, at least for the next foreseeable 50 to 100 years. Not to use it to burn it up to make all the power, but just to float and take care of the demand rate that's on the grid. You got to control the grid. By the way, you just got to talk to someone from Bonneville. They'll tell you about the story. Now, here's the 4 types of methods that we have a choice from if you're going to float turbines. You have on the left, you have a barge. Well, there's only one good company right now. The French and the Europeans have put together what they call Ideal, and I'll cover that. And here's Principal Power, the next one, which is kind of a semi-floating device. That's the one we worked on 4 or 5 years ago and developed the engineering and the constructability of how do you get that thing built in Coos Bay, how do you get it out the bay, and how do you bring it back? Because if you can't figure out how to bring it back and work on it, they won't let you put it out there in the first place. And then there's the spar. That's the only one that's actually gotten any commercial traction right now. It's the one over in Scotland. It's an eloquent design, as I call it in engineering. We're working with a company called Wind Creek, who is a joint venture with University of Stuttgart and Spain, and for concrete, all concrete unit. By the way, concrete, according to DOE, gives you a 60-year life. Steel only gives you a 25 to 30-year life. So for a developer, that means a lot. In fact, England now is converting from jacketed metal supports for their ocean-based ones, their floor-based ones, to what they call gravity concrete. All their new units are all going to be concrete because they recognize you get twice the life cycle cost, twice the life in your formula for our life cycle cost, which is critical. That's how developers evaluate which kind of system work. It's all about life cycle cost. And then there's the tension leg. It's kind of a unique little thing. It hasn't gotten any traction yet, but I thought I'd show it. And of course, just to give you a perspective, I caught this picture because there's all the little people and there's the big turbine. That thing weighs 9,000 tons. Now, all the turbines here before the Siemens was like about 500 tons. Now, we had to bring the largest crane in the western United States in to lift the Siemens 8-megawatt turbine for the Coos Bay project. Cost $1 million to bring it in. Comes in pieces. It costs $1 million to take it back, and it costs millions of dollars every month to operate it. This thing is twice that size. And I'm going to show you why we think there's a solution for, by the way, Siemens will be the first to say we have an NDA with Siemens and GE. Siemens has told us we have no visible floating structures today to handle the large turbines. The SPAR comes the closest. It's operating in Scotland. I forget how many megawatts is out there. But I thought that that gives you a little bit of perspective to some of the different buildings around the world. Here's the floating spar. This is Wind Creek. This is a company from University of Stuttgart. They don't have a demonstration unit. We're working with trying to get the first demonstration unit in the Pacific Ocean. By the way, there is no demonstration units in the Pacific Ocean. That's a major factor right now. It's all concrete. And by the way, it's all concrete tower. It's a whole concrete thing. And why do you need that? Well, I'll show you in a minute, because nobody's figured out yet how to put that 10,000-ton monster GE up 500 feet in the air on a tower. Wind Creek figured it out. We'll show you how that works. This is the competing one. This is all metal, unique, but the problem with it is you have to have a fjord around. Norway's got lots of fjords, but you got to float this thing, and it's 400 feet down in the water. Now, most ports don't have that kind of depth. So, even, by the way, I call them the company, is it Highwind? Yeah, Highwind even now says that metal is too expensive. This is a all metal unit. It takes $1 billion worth of shipping, specialized shipping ships to even mount all that out in the ocean. We have none of that in the West Coast. Everything on the East Coast right now is all being done by European companies. It comes over, it's being done. It's basically a European project. We would like to see it in the West Coast to be either a Coos Bay project, or we'd like to see a Coos Bay project. But by the way, we're going to need a lot of help from the Oregon, Salem, and the port to do that. I mean, we can do a lot of things, but there's a lot of infrastructure, system, and just focusing the energy. Oregon has a hard time focusing their energy on anything to get something done. We need to do that, and I'd be more than willing to help. Anybody knows me, I'm a very focused individual. This is the barge unit the French developed, and it's a great thing, and it's going to be one of the major ones to consider. It's all concrete now. The first one's metal, and this is the principal power one. This is the one we were going to put off the coast. We had to make those things here. We had to build a special fabrication shop for about $20 million because we had to roll 10-foot sheets, 2 inches thick material to build these things, and we had to have all new different kind of shop to do this. We could not do this in our shop. By the way, here's a facility. By the way, guess who? That's our facility over there in that little dock. Have you noticed some of those pictures of some of those docks in Europe? Ours isn't a good pimple on you-know-what. This is a spar system. We've come up with we figured out a way to build the principal power units. We'd have to use a low water graving yard. Basically, clear down to the RV park we were going to buy the RV park and build principal power units across the bay. But you notice we got something we got an airport, FFA, that says we can't use anything above 160 feet, which is a problem. By the way, it's also a problem at Humboldt Bay. They got an airport there too. So I'm just going to show you how unique, how eloquent this has solved the problem of putting this 1,000-ton monster up in the air 500 feet. We cast this in concrete. What I showed you was the form. The form is the barge. And then we just literally take the shell off, and we sink the barge, and we float this thing out. By the way, these are our AutoCAD drawings because the drawings we got from Wind Creek, they're in a form that we couldn't use. So we had to create an AutoCAD in our own drawings. So they're simple drawings. They weren't meant, we just did these yesterday. It took us about an hour to show you the concept. So you float it out, you ballast it, tips it up, and that's like that. Next thing is a barge. And by the way, that barge has got 2 of those 1,000-ton GE units on it. If you notice, those things are right there. I wish I could point at them. There's a crane in between them. We don't lift the Nansill. We hydraulically lift the spar, the tower, up underneath the structure and lift the Nansill up in the air. That's what they call the generator, by the way. It's called a Nansill. It's kind of a French term. I never do pronounce it quite right. And then we have a ring crate on the, by the way, that's 2 barges with a special structure, a very special structure. So it's split. Literally it pulls up, anchors onto it, so the barge and the spar is one. That's what they haven't figured out yet. And a lot of this thing, out in the ocean, nobody's really figured that out. How do you make them go as one? So that you can actually, if you're lifting 1,000 tons up, anybody in the ocean knows, you don't want that up in the air swinging around. You have to have it very stable, and you have to have a stable platform between where you're lifting it from to what you're setting. So you just keep balancing it up, and the ringer crane will put the blades are 40,000 pounds. They're not a big thing. So now I'm just going to show you our facility. That's the ideal. We can cast the ideal, which is the French version. There's 2 of them, by the way. There's it being casted over in France. That's a 3 megawatt. The problem, they haven't gotten above 3 yet. They built a 2 megawatt metal unit, but all of a sudden they woke up and says, we can't use metal anymore, or we have to go to China to get our structures. And that's the competitive thing we have with Principal Power. In fact, with Principal Power, we suggested to them that to make it economical, that you ship those units separately, and then we will assemble them in Coos Bay on a submersible barge so that we can basically have the methodology to not only float them out in the ocean, but we can also pick them up and bring them back and do maintenance work on them. So, because it's almost impossible for us to compete with South Korea or China when you have big steel structures. Even California had to buy their Oakland Bay bridge, their new bridge, they had to buy it from China, okay? Nobody could provide anywhere close to the cost or the quality of the construction. So I'll come back to that. I finally figured out how to use this. Come on. How do I get the next one there? Okay, we can make 3 spars. Now, we had a developer call us 2 weeks ago. He says, Dennis, we need 300 megawatt. We're looking at a 300 megawatt farm. Can you make those spars enough in 2 years? And it takes 25, and it takes us 3 units to make 25. And I said, yes, we can make those. I described how we're going to make them. He thought that was kind of clever. Here's the Principal Power unit. We could build the Principal Power units here, or assemble them. So we can assemble anything or build anything. There's some infrastructure that's going to be required, and I don't think that we can carry all the full load of that. We'll carry some of it, but we're going to have some help like they normally do in Europe and Northeast. The states do help with some of the infrastructure. By the way, for us to make those spars, it would take about 700 people, employees, to do that. This is the last slide, so I hope I'm making this short. I've lost track of time. Oop. This is just, this is controversial. I know, but anybody knows me, I've always been controversial, so this is no exception. Here's a 1.5 gigawatt, what it might look like. Now, this is out past the 50 mile. How do you get out past 50 miles in 9,000 feet of water? Well, I come up with a system that you connect the spars. By the way, this is spars. You connect them to each other. and you only have tether lines on the outside. And then I had some commercial fishing people. David brought them into my office, and I just sat down and talked with them. I says, what do you folks want? He says, well, we want to be able to go fishing out there. And I said, well, how about a corridor between these so that for you folks to go down fishing? And by the way, you can salmon fish in between all those, because those little ties you got between them to support them, they're 50 feet under the water. So as long as your boat is not more than 50 feet, you're just fine. You'd have a hard time getting through that if your boat was more than 50 feet. But something has to be created to use Oregon off the coast. We're too limited. And I don't know where the most valuable real estate out there in the ocean, and that's not my role to determine that. It's going to be a lot of collaboration between the fishing community, et cetera, to determine. But I just tried to come up with something that would allow us to use our potential. If we were able to do this, get past the 50-mile, we can generate enough power to run the entire United States. Now, that's kind of scary, I know, but I'm a visionary. I've always been a visionary. Talk to any research chemist, engineer, you'll find they're visionary. You have to be. You get so many negative results, you got to be positive, and you got to just have the vision of where to go. This is just a vision. Don't go after me because, oh my God, here. Oh, by the way, there's a little fishing boat out there. That fishing boat is 50 by 250, and it's dragging a net or whatever it wants to drag through there. And the fisherman said, well, we need a north-south corridor, because that's how we fished. I said, you mean you don't want an east-west? No, we don't want to run into the beach. No, we want to go north and south. And I happen to think back to all the fishing boats I see out there. They're going north-south. Okay, so this is north-south. Just a simple conversation. We had a tentative, at least he said, at least you're talking to us before you're telling us what you're going to do. And so so the ideas of different people in the community can be integrated, not at the end, but all through the whole process. So that's all I have to say. I appreciate your time. Ron, thank you for having this.
Thank you, Dennis. I figured that David said 20 minutes because he knows you, and he figured you'd go closer to 30. So. And when you said last slide, that was good. Then I didn't have to bring the hook out. So that was a bonus. So our next speaker tonight is Shannon Souza, and she's a professional engineer. She's also CEO of Soul Coast Companies, and is, here, I'll go for this one, and is, yeah, I like this one better, and is Oregon's 2019 Professional Engineer of the Year. She's been practicing sustainability consulting and contracting to support strategic growth, responsible development, and sustainable living. Since 1994, she and her company have championed or collaborated on triple bottom line projects that result in net benefits to the economy, society, and ecology, such as habitat restoration, public water supply development, and distributed renewable energy generation on the Oregon coast. She's the recipient of Weyerhaeuser Company's President's Award for contributions to paper mill environmental impact reduction, and is also a water rights examiner and professional environmental engineer in the state of Oregon. Shannon's on the board of the Professional Engineers of Oregon and serves as policy chair for the Oregon Solar Energy Industry Association, where she has been focusing on state and regional energy markets and infrastructure. And yesterday spoke at OIT, and tomorrow is back to Canyonville. So even though she lives here, she's doing a little bouncing back and forth to join us this evening. Shannon.
Okay, I'm going to set my stopwatch so I don't go too long. I'm very, very excited to be here. This is definitely one of those triple bottom line projects that I know you hear kicked around at the pub and people scratch their heads and say, why aren't we doing this? Why haven't we done it? Very much thankful for the efforts that we're taking to bring those together that need to get together so we can put our heads together and find out what the barriers are and where we can go. I'm going to focus a lot on this what's going on in terms of our infrastructure, our existing energy, electricity infrastructure. I'll talk a little bit about the market, but there have definitely been some other slides on that. This is one of my favorite nightmare images. What this is an image that shows all of the existing electricity transmission lines that we have in the state of Oregon. And each of those circles is a location that we generate electricity on those lines. I'd like you to take a look at the coast of Oregon. We are definitely lacking in circles. So that has been part of my impetus in focusing my volunteer activities recently on distributed energy generation. So let's put us in the middle of everyone. I'm really sorry about the cheesy grass thing on the bottom of these slides, but it's there. I couldn't get rid of it. So looking at this, this is another kind of nightmare picture for me. We Oregonians really pride ourselves on being able to take care of ourselves. But if you look at this, something very stunning comes to mind, at least what I see is we are relying on imported electricity for everything that we do. Everything that we do now, and we are making statements about wanting to do even more things with electricity. Let's put this in context. You heard a little bit about these renewable portfolio standards. Lots of states have them. We have our own. In Oregon, we have stated that by 2040, we want 50% of our electricity to be derived from renewable energy. If we go up to the north, they just passed their own Senate bill for 100% carbon-free by 2045, and as Dennis said, they've been really leaning heavily on hydro. As you know, with climate change coming through so quickly, interesting, kind of the elephant in the hydro room, is that that entire infrastructure is based on snow capturing and storing that potential energy for us. And we're looking at, more precipitation, but it's a warmer precipitation, so it's not going to be held up in the mountains. So certainly hydro is here to stay, but there are a lot of adjustments to that infrastructure that will need to be made to adapt to our changes there. Then we look down at California, Senate Bill 100, of course, 100% renewables and zero carbon. So look at these dots. Those are obviously not geographically sized. Those generation locations aren't that big. That's how much electricity they are currently supplying. Now, keep in mind that all of those black dots, the dark gray dots, any dots that you see that have to do with petroleum, with natural gas, with coal, are going to leave that picture in the next 20 years. And that's what's supplying us all right now. Let's also take a look at what we're projecting out in the future. So we're not yet even meeting those demands that we have. We're looking at population estimates to grow 17% in the next 20 years, that same 20 years on the West Coast. California's market, 5th largest economic market that we have in the world. Today, this, I grabbed this today from California just to see, okay, what are their renewable generations totaling here? And let's compare that with what are they actually consuming now, and what are they projected to consume? So they're not meeting their renewables right now. They have invested a ton of money in them. If you're going to pull a new permit for a new house in California as of January 1st, you need to produce as much electricity on your house as you consume in the year. That's a busy little map. That's all of the transmission lines that we've got all over the place. And depending on what scope you're looking at, there are larger and larger groups of decision makers that get together and decide at the federal level, where should our infrastructure dollars be targeted? So let's take a look, just grossly talking about what those electricity markets look like now. That's without the renewable portfolio standards. Average cost of a kilowatt hour, that's what you get billed for by the utility company every month, is 13 cents across the United States. Up in Washington, where they've got super cheap hydro, it's just under 8 cents. Oregon, we're a little bit more at 9 cents, but wow, look at California already, 18 cents. And that's the average. If you're using that electricity at the wrong time of the day, it's about 30 cents a kilowatt hour. Notice I wrote this CCA's wild card. California is the wild west of the energy market. In Oregon, we have an infrastructure that was built out and is managed by private investor-owned utilities. Same infrastructure deal down in California, difference being that they have independent suppliers all over. And recently, in the last 5 years, have been developing what are known as CCAs. These are community choice aggregate. That means a community in California, say Humboldt, can opt in and decide, you know what? We only want to purchase our power from an offshore wind, or we only want to purchase our power from this supplier. They can decide, that's very different than the market that we have. So now we have not just the sheer volume of the dollars and the electricity to be served in California, but a very dynamic market that leaves the door open for more nuanced negotiations of what those development packages and infrastructure build-outs will look like. So certainly in Oregon, we've got some work to do, and certainly we've been doing it. This is a picture of our solar dashboard in Oregon, what's happened in the last 18 years. So we've definitely been doing a lot. But we've been putting the brakes on. Yesterday I was speaking at OIT, and the topic was on solar facility siting and interconnection barriers, both of which we have significant ones. So as alluded to, not just in California, but also in Oregon and other states, we have increasing rigorous policy against siting large solar and wind farms. And over here in Klamath, where I was speaking, where we do have the transmission lines already running through, even if we can get permission to put in a wind farm, PacifiCorp has not even conducted a study to address any new interconnection applications in at least 12 months. And their queue is growing and growing. So there's definitely some opportunities for improvement. Interconnection with the investor-owned utilities. I'm going to kind of tell the same story that Dennis did, but I'm going to talk about the energy sector. Let's see. The existing transmission lines are insufficient to support significant export of Oregon energy to the California market. Fact. That's where we're at. You want to know why we're not on Odo's site? Because they're thinking, or Department of Energy site, they're looking for the ease of interconnectivity. They want to do this as close as possible to that huge market and those huge demands. So if we're looking at this as a phased approach, which is to say we want to get in on that California market, even if it's directly connected to the California grid, but we want to build and deploy and maintain from Coos Bay. Yes. At the same time, I would encourage us as a community to continue to pursue and advocate getting on this map for transmission and interconnection development here. So in California, that's their independent suppliers. They get together with the big wigs all over the Northwest, and the independent suppliers put together preliminary studies, say where they would like to see some transmission because they can see a market for that, and then it gets pushed up the FERC process. So as of right now, this is where the federal dollars are going to invest in infrastructure to supply that market, over to the Utah and Wyoming wind farms. Talked a little bit about that. So over here, if you're not familiar with the Oregon PUC, and if you are interested in sustainable renewable energy development in Oregon, you should familiarize yourself with the PUC. All of their meetings are public. You can stream them. You do not have to show up in Salem, and if you want to, they'll give you a call-in number and you can participate. Why do we have a PUC? Because the investor-owned utilities have a monopoly over an essential commodity for us, which is electricity. Senate Bill 978 back in 2018, our legislator said to the PUC, hey, you guys, you've been doing this since 1911. I think maybe you should look at what your mission and goals, mission and vision are. So they did, and they've updated that. This is very new coming out of the PUC. Was able to participate in that process. But if you'll notice, equity, meaning service to the rural communities, clean energy, customer options, and participation. Those were the findings, and that's the focus. So now is a great time to get to know your PUC and speak up. And just so I can really put you to sleep, the PUC opened dockets. You don't just show up at the PUC and start talking about anything that you want to. The commissioners determine an agenda, and they determine dockets of areas of investigation that they direct their staff to investigate and invite public input. Right now is a completely transformative time at the PUC. They are simultaneously looking at the staff investigation of PURPA, that's looking at renewable energy generation projects and making sure that private investors have access to their transmission lines. Interconnection transparency, distribution system planning, general capacity, how are they going to supply their needs, and their integrated resource plans. Those all have direct impact on us being able to someday supply our own needs through offshore and export that to the California market. So, summary, I've just got two more here. In terms of the market, the West Coast State Renewable Portfolio Standards are demanding unprecedented development in renewable energy generation, absolutely astronomical. Our population forecasts, and we didn't even talk about the increased demands that will come from our electrified fleets. And the California open utility market is lucrative and flexible and dynamic. Infrastructure. Offshore wind can supply a peaking winter resource to balance that southwest solar resource that California is now reliant on. It's called the duck curve that they're trying to work out. We would love to step in and help them stabilize that. Offshore Wind Coalition, I'm talking about us here, and those that you network with, we need to engage with the PUC on this topic. And a DC transmission link off the coast that somehow gets Coos Bay to Eureka could and should be compared to existing investments that are being considered to develop the interconnectivity to Wyoming and Utah. Thank you.
Thanks, Shannon. Our next speaker this evening is Samuel Baugh, and he started as the Executive Director for South Coast Development Council, or the SCDC, in August of 2017. As the Executive Director, he feels a personal responsibility to grow the economy of Oregon's South Coast. The SCDC mission is to promote and support businesses that provide quality jobs through reasonable development on Oregon's South Coast, which includes focusing on sustainable industries being brought into the region. Currently, Sam serves on multiple boards of chambers of commerce and downtown associations over the entire South Coast. Sam was a founding core team member for the Oregon South Coast Regional Tourism Network, which earlier this year won an award from the Governor's Office on Tourism for its innovative partnership program. Sam is excited to help the area grow and expand. Sam.
Thank you. I appreciate the opportunity to come and speak with you guys today. I know everybody's anxious for my 3-hour presentation today. I've been asked to actually talk about the economy in the area, and our good and our bad, our ups and our downs. I want you to just kind of take a look at some of these things right here. This is the state of Oregon compared to Coos County. I hope none of this is that surprising to anybody. We have a higher employment rate than the entire state. Unemployed in the entire state is 81,000. We have 1,300 here in Coos County. Labor force participation, that means how many people that live there are actually working. The state average is 63.2%. We have a 49.8%. What does that mean? That means not everybody is participating in our labor force that is possible. Population growth, 54,200. Our population growth, -35. Okay. Our job growth rate is on the state is 2%. Our job growth rate here, 0.5%. Jobs added in the state, 38,000. Jobs added here, 120. That means we have some ground to make up, right? So our wage information in the region, excuse me, our state average private sector wages, the state has 52,089 is the state average wage. Coos County, 37,103. What does that mean? We're 29% below our state average as far as how much people are earning to live here. What they call this a CAGR, compound annual growth rate in wages. The state over a 10-year period increased by 5%. Our region, that means Coos, Curry, and Douglas County, and that's the smallest they'll let me factor that down into, grew only 0.1%. That means we're growing at 80% less than the rest of the state as far as our wages go. Who's excited about that? Woo, woo. Okay, nobody. That's great. Again, we're going with our compound average growth rate as far as employment. Through the private sector, same 10-year period, the state was growing at an average of 1.3%. Coos County grew at an average of 0.5%. Again, we're not even keeping up with the rest of the state. Gross domestic product, the state per person is averaging at 50,655. Uh-oh. That's per capita GP. And Coos County is averaging 27,670 per person. Again, just showing that we're falling a little bit behind here. This is not, there we go. Our private goods percentage total, the state is at 20.8%, and Coos County is at 23.3%. So as far as private goods, we're actually above everybody. Good, bad, indifferent, I'm not exactly sure, but that just means we have 3% more of our goods privately owned. As far as our GDP growth, again, Oregon is growing at 3.2% and Coos County is growing at 1.5%. So, what really drives our economy? Traded sector businesses. What a traded sector business is we are bringing wealth from outside into our area. These are things like manufacturing, when we fishing, timber, tourism. Tourism is considered a traded sector because we bring people in, they spend their money here, and they go. When we manufacture something, they come, they spend their money here, and then they take stuff with them. And so that is what actually drives our economy. And this is a good quote from the National Association of Manufacturers. It says, broadly speaking, every dollar spent in manufacturing adds at least $1.89 to the economy, which basically means every one manufacturing employee results in the addition of nearly 4 employees elsewhere in the area. So for every one manufacturing job, that means we generate 4 other ancillary jobs. That's the individuals that build houses, that run the shopping, the retail locations, all of those things. So this is kind of the economic development cycle. And up here at the top, you have those manufacturing jobs. And what those jobs do is they bring in the money from the outside, and they pay their employees, which turns into earnings. And those employees spend it, which then creates more businesses. The businesses then in turn create a community, and the community in return, again, creates more jobs, because we need all of those, we need those other ancillary jobs to continue to So a retail location will pop up, and they will pay their employees, who then spends money, who then has a need for another business, again, grows the community, and just keeps going around in this cycle. All right. So this one's going to be a little tricky here. This talks about our top location quotients, traded sector businesses in our region. Traded sector, a location quotient basically means we do something better here than they do anywhere else. They don't throw things like hospitals into this. They don't throw retail locations into this, because everybody has a hospital in their community or fairly close. It doesn't take into account retail because everybody has shopping in their communities. What this takes into account is how concentrated that unique job is. And so basically, I need to go back. Our plywood and engineering and wood product manufacturing in our location has a 72%, what's the word I'm looking for? It's 72% more available here than if you were looking in somewhere else in our area, and this is throughout the United States. Again, and we employ 2,500 people in that, and with an average wage of about $50,000. You can see this logging is at 68%, support activity for forestry is at 60%, sawmill wood preservation is at 43%, timber tract operation, again 39%, and fishing is 33%. What this tells me, the top 5 is timber related, and the 6th one on that is fishing related. And they all have good, decent wages, which is what we expect from a good, solid traded sector business. Now, this here is the one that sometimes scares people. Support activities for crop production. Again, our location quadrant is only at 1.24 because we actually don't have that many farms and crop productions. But it went up by 1,913% over a 10-year period. That's amazing. Can anybody think back to about 5 years ago? What happened? We legalized marijuana, and we had a lot of farms pop up, and that actually contributes to that number. So you may look at that and think that grew an astronomical percentage rate, but it really only grew 172 people doing that farm. But since it was quite a high number. Now, veneer plastic, plywood engineering, wood products, that grew by a 23.2%, which means we added 527 jobs in the last 10 years. Other wood product manufacturing, however, we lost 72 jobs. And we are at a negative 20% as far as growing that that specific industry. Now, our support activities for the forestry, again, we lost 190 of those jobs, which means we lost 33% of that industry in our region. And so that doesn't make a lot of us happy, because we want a vibrant, thriving economy, correct? Okay. Is everybody awake? It's still, okay, all right. Glad you guys are out there. Now, this is a quote from Mike Myers. He's a Business Oregon economist. He said, "Forest and wood products is the largest competitive industry group in the region." He's talking about our Coos-Curry County region. "But its decline means other competitive industries must be developed for the region to grow." And so, as a community, we need to be looking on the outside, saying, what are we not doing here that could possibly be one of our strengths? And honestly, when we look at that, we have to come up with this question of how do we become competitive as a region? How do we do these things? And I think both Mike and Dennis and Shannon, who went before me, they really talked about the thousands of jobs that are available in wind energy. The UK has 20,000 people involved in this industry. Germany has 27,000 people involved with this. And Europe has an average of a $50,000 wage per individual that is in this. What if we could grab just a fraction of that? What if we could grab just even 10% of that? That's 2,000 jobs in our region paying an average of $50,000 per person. Would that help our region and our economy? Absolutely it would. That would help us be competitive. That would help us continue to grow and drive people here. And then, of course, that's just the 2,000 people working in that farm. What about all the supply chain routes, the jobs of the ancillary industries that need to be in to help support those locations? We are at a turning point. We need to look at what we want as far as our area, as far as our region. What is it that we can do? And if this is one of those things that is going to drive and help our economy, this is something we need to look at as a community and say, how can we make this happen? Thank you.
Thank you to Sam for getting us back on schedule. And another Sam, Samuel J. Schwarz, is a local lifelong resident, and as an entrepreneur, he has been operating multiple businesses with headquarters located on Front Street in Coos Bay. Sam was awarded a U.S. patent in 2013 for a lighting device that combines energy-efficient LED illumination with unique blown glass diffusion, and is underway with expanding manufacturing capacity of lighting fixtures in Coos Bay. He quizzed me on this before when we were loading stuff, and I said, "Oh, you mean the cool lights at Seven Devils?" He said, "Oh, okay, you know." It's like, yes. Sam is very excited to explore the offshore wind potential for clean energy, job security, and economic stability for our community. He is dedicated to working with community partners for the long-term health and vitality of Coos County. Sam Schwarz.
Wow, what an honor to be here with you guys tonight. Can I pull this out? That one comes out? Okay. So here's to looking at our future. Meet Zariah. She's standing in front of a lot of people think that wind energy is not so beautiful. I think that corrects the misconception. We are at a pivotal point here, and I'd like to reiterate that what Sam Baugh said, and I'm so excited to be at this point in Coos Bay and this pivotal point, and so honored to follow up in the conversation with our other speakers here tonight. There's a lot of information. I will not be sharing a lot of detailed slides. I have 3 images I put into the drive just before this presentation here tonight. I've been extremely busy down in Langlois installing an exhibit with my lighting, and I have some images of that coming up. So really, we're here for the future of energy, and we have an amazing opportunity in Coos Bay and for the state of Oregon and the United States of America. As far as this, we're going to put Coos Bay on the map for changing the tide in energy dominance, no longer being reliant on fossil fuels and dirty industry. You know, 20 years ago, Dennis, I worked for Lon Samuels Architecture, designing your office spaces over at DB Western as a draftsman right out of high school. So what an honor again to work with you. And then with Shannon, for years I worked installing solar photovoltaic and solar thermal on the Southern Oregon coast. So I've had my hands on renewable energy systems for a number of years, and moving forward, this little power station I put together in an afternoon just a few days ago, and this is at the Langlois Cheese Factory. I asked them actually, like, what do you say? Is it Langlois? Is it Langlois? Langlois, okay. Well, it's French, and then you could even say Langlois, if you like. So this is a Solar World 350. There's a couple of 6-volt deep cell batteries back behind it, and like a 400-watt little wind turbine on the top. And so it's kind of hard to see back here, but these are all trees made out of copper, and the blown glass on the ends. You know, and I'll just jump right forward. These actually, we put 12 of those trees up this afternoon. This is the kind of manufacturing that I want to do here in Coos Bay on offshore wind energy, on renewable energy systems, and paving the way for other clean technology manufacturing in Coos Bay. And it's kind of interesting, what role am I playing here in this entire project? I was more recently chair for the Surfrider Foundation because of my love for the environment and the ocean and clean water. And we're always, you know, looking for some kind of a savior in manufacturing or some kind of big company to provide all those jobs for us here locally. And I really think this is it. I think this is the one. I think this is the one that we can all stand behind, the environmental community, the industrial community, and we can really link our forces and move with a lot of energy towards this potential. Now, how that's going to look, it's going to be a road with a lot of hurdles. And the fishing community, I also own a commercial fishing boat, and we fish for albacore, and so we will be fishing in those grounds where these turbines will be installed, 18 to 25 miles offshore. And some fishermen might not like that, but we can work with them, you know, because it's crucial. This is a turning point, and I'm willing to dedicate my energy moving forward to helping our community come together with momentum to support this project. However that may look, and who the partners may be, and what the actual turbines and the height and all the technical details will get worked out. So these are 2 chairs. I invite you to sit in the garden of thoughts. And how can we engage ourselves in this project? It's going to be talking to other members of our community, and you know, and just talking to everybody, and really building that momentum moving forward. And I think this is probably the first of many presentations and discussions that are kicking this project off, and I really look forward to how it all unfolds. I'm not going to bore you too much longer. I think we'll just kick it back to Ron and open up for questions. I'm just going to set it down. You want this one?
So first and foremost, thank you all for coming out tonight. We've got a couple of microphones over here for Q&A so that I don't have to play Phil Donahue like I normally do. And if I can have the other 4 presenters come up, I'm going to let you share this microphone and go back and forth dependent on who might be the pertinent one to answer, multiple folks to answer questions.
Okay, go ahead, Pam.
Okay, thank you. Thank you very much, all of you, for dedicating your time to come and talk to us. This is really an exciting time for all of us, as you indicated. My question, and I may have missed it, but when you talk about the turbines, how were they anchored? I kept seeing anchor, 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 but I didn't notice how they would be anchored.
I had that in my slide stuff, but I didn't have enough time to cover that. The anchoring is absolutely critical. Without it, you can't have a wind farm. They obliquely cables, or they have synthetic ropes, chains. They oftentimes, the best technology now, I think, is synthetic ropes with chains to provide kind of a spring attitude, and they come down obliquely off the, obliquely is about 15 degrees off, and they anchor into the floor with suction piles, often suction anchors. That's the most notable ones. They are the strongest. You have to use the fewest number of them. They're nothing more than a big 15-foot diameter tube that they suck down into the ocean floor, and they serve well.
And we don't have to worry about the earthquakes with those anchors?
Well, with earthquakes, I'm not sure too much of that is an exact science, but generally speaking, the anchors, I would be more worried about what they call a plate anchor, which is very surface mounted. These are anchored down reasonably deep. There's multiple units, and I showed you that one grid. So sometimes strength is in numbers. In other words, if one thing fails, you still got a lot more of them kind of tying the network together.
Thank you.
But that's a weakness.
Thank you.
Andy, good job, thank you. Thanks again for coming here. And there is some urgency, as folks have said, and because we are not even on the map at this point. And I'm kind of a cast guy, and I'm thinking, you know, this is a great presentation. I love the presentation. I think the potential's there. I would love, if we could today, have only wind and solar and no fossil fuel. I absolutely think it would be marvelous. Reality says it's not going to get it. But where do we go from here? You guys are up there fine with it. What do we do now? I'm here. I'm ready. Put me to work.
Well, I'll chime in first, and then I'll hand that off. I will reiterate that I am actively engaged with the PUC, and I would love for more advocacy from our coastal region with the PUC, and would be happy to work with others that might be interested in working in that sector.
One group I think that if we'd love to see you come would be Boost Southern Oregon. Our mission is to make sure or try to keep the economic life of this community going. So that would be a great one.
I spoke to the governor, when was it, Saturday? Wednesday, Thursday night, sorry. She wants me to provide our presentation to her. She's obviously interested in offshore wind, but really, in all fairness, I've talked to Bonneville, I've talked to PACCOR, I've talked to the developers. I think I've talked to just about everybody in terms of who has the capability to make things go. What I see is where our weak spot is. Oregon's got to focus. I think you've got the developers who've got the money and got the inclination to do this. You got California pushing the drive, and there's the market. Our electrical cost here is low compared to California. Our drive is not so much, but the market is in California, and somebody's got to, and the government has got to be focused on helping this thing. That's what's happened on the Northeast. The governor and the legislator people, look at what's happening in Washington, California. It hasn't happened in Oregon. So you need to talk to your legislators, your representatives, and just say, you know, it's time you get with it.
I would also underscore contacting Senator Roblin, who's highly active in regional energy resource. That's definitely a good direction to go.
I've spoken to Katty McEwen also. She's actually in favor of this project, but I would underscore that when the politicians and the other leaders in the state understand that the community's behind it, then they'll put together a task force and do it like all the eastern states did. Set up a task force, find out what the wind developers need, and start making that available to them.
I know this discussions have already started. I sat in a meeting up in Newport about a month ago with POET, the Pacific Ocean Energy Trust, and Boehm was there. Arnie was there, Caddy was there. So yeah, the discussion has already started, but again, reach out to your legislators and just say, hey, look, this is very important to us as a community. Let's make this happen, and let's not stop this conversation here tonight. Let's keep this going.
Absolutely, I couldn't agree more with everything that was said. This is, if we show that our community is engaged and united moving forward, then that definitely shows a lot of power and a lot of strength towards this project moving forward. It's so powerful, you know, when our community is divided, nothing really happens. And so this is an opportunity for us to engage the entire community, have that conversation with your neighbors, with the members of Boost, with whatever other members that you're affiliated with, and get signed up on those forms outside for contact information with your email addresses and your phone numbers, and spread the word, and anybody else that you know that might be interested or might play a crucial role in moving the conversation forward. It's time to have that conversation.
Let me just clarify, the lovely green forms are just my way of keeping track of names, rough ages, and locations. There's no email or anything on that.
Oh.
So unless somebody else put a contact list out there, the green sheets are just what I do for free talks in order to justify the existence of free talks.
I just wanted to add one thing we left out, very important, and that's the port. The port is going to have to be proactive business. And if it doesn't start getting proactive business, then nothing will happen in Coos Bay.
I'm glad to hear you say that. That's exactly what my question is. The part that's missing so far tonight, as far as I can tell, is where does the port stand on this? The port's in charge of ships and what goes on there, but also they're in charge of something that the Eureka does not have, and that's a railroad. A lot of the parts for stuff that we're talking about can come in by ship, but also a railroad able to deliver to the waterfront is a real important advantage. The Port Commission, the way I understand it, is actually our window to go to the governor. The governor has appointed our port commissioners, therefore they should be able to take the lead from here to talk to the governor, who can then talk to the legislature in our for us. So what I see missing is where are the port commissioners on this? If they're not behind it, it's not going to go anywhere.
Do you want to say that?
Well, as far as I know, and this is what I was told, is the port was invited to be here tonight, and they declined the opportunity.
There you go.
One other piece of information, we have the premier piece of property of 40 acres with a dock, and the port has 120 acres all around us. But the only place that we're going to have deep water activity in Coos Bay is probably in our property, in the port's property, which is basically west of the railroad bridge. Nothing's going to, for the size of ships that got to come in and to support this project, it has to be truly deep water with no overhead restrictions, which eliminates everything above the bridge. So the port has the property, and the port has the wherewithal with the governor, and they have the money.
So I'd just like a clarification point. To the best of my knowledge, I got the list of 5 people from David. He didn't invite the port. I went off of the list of the 5 of you, so I wouldn't automatically go that the port was invited to participate and declined unless somebody else did that.
Hi, yeah, I just want to thank you so much, and it's obvious that we are going, this is our future, and we are right in the beginning of it. And it's awesome that you guys are here, but you've answered so many questions already for me, but I'm kind of concerned about the fact that Mr. Beethan said that you think that natural gas is still a bridge. And so how are you going to get those, how are those I mean, if LNG comes here, God forbid, this is the whole point, we want wind turbines. I mean, as an alternative, I personally do, and I'm sure billions of other people do too. How are those big LNG tankers going to navigate through your wind turbines? God forbid that is a scenario, but I mean, is that a reality anywhere on the planet? No.
I don't see a problem with it.
You don't?
I'm very familiar with the LNG project.
Yeah.
Those tankers come in very infrequently.
Mm-hmm.
Our floating concrete units are going to go out very infrequently, and I think there's plenty of place for both parties. In fact, by dredging the bay out, if it happens, or the LNG project, I think that would be a very positive thing for these big ships that have to bring this big stuff over from Europe. GE turbines are made in France. They're going to open a factory in China. All the turbines, almost all the infrastructure materials, if we want to go to a DC current and want to convert that to AC, it's Siemens and ABB. They're the two people in the world. We worked in Hawaii on a 450 megawatt farm. And, oh, by the way, you need a DC grid. That's a problem. Why? San Francisco figured it all out. They have a DC grid going over the bay, and they found it does not impact inductive current, does not impact green sturgeon, salmon, or whales. And that was the most critical thing in Hawaii when we ran into it, was whales with an AC current. The inductive current is very detrimental to whales and their migratory habits. So just so you understand that, in my opinion, we need a DC grid. And if you don't know what a DC grid is, it's about 30% more efficient in transmitting electricity. There was an article about how many nuclear plants you could shut down right now if we had a DC grid. We don't. Bonneville is putting in a second one in from Bonneville toward the border, but what we heard tonight, Oregon can't transport across the border. Some of this stuff has to be done by federal government to change some of these rules at how you transport renewable energy across the border. Bonneville's putting in a second DC grid to the border, but there's nothing on the coast. We would have to put a DC grid all the way to the Dalles to get on the hub of the DC grid. That came right from the Bonneville people that I've talked with.
And where would a person find more information on this type of grid, and as far as how much environmental damage it could do to our offshore fishing industry and so forth, or not? Is that not a problem?
Sorry, I didn't understand your question.
Do you think that DC grid, the implementation, will be a problem for our natural, aquatic?
Absolutely not. It's already been proven. It's being used all over Europe now to transport hydropower from Norway down to Germany. Europe is way out in front of this, and that's why they went to the DC grid.
So far, so
Underwater, DC grids are running 500,000 volt DC grids all over the world. The United States has got the fewest DC grid. China has completely done a complete DC grid across all of China. And we're sitting here with just a very few DC grids, so infrastructure along that line is going to have to start coming from our federal government.
I see. Just one more part of my question, and that is, I'm really pro-Green New Deal and green energy and renewable and sustainable. I'm completely anti what you were speaking about, the transition of LNG. I don't believe that we really truly need that to transition. And can we go wind? Can we go total wind with it and make a lot of jobs here without all of that other LNG stuff, do you think, successfully?
Okay, I'm going to be very honest about this. I'm not going to pull any punches. I'm not going to be politically correct. I know what's going on in the world. We study what's going on in the world, especially with Japan right now. Just 5 or 6 years ago, they did away with their nuclear energy. They're now headlong, just like we are. They were behind in offshore wind. They need offshore wind. They're going crazy to get it. But without a source of energy like natural gas, not to burn to make electricity in a power plant, no. To do like what Oregon and Washington are doing, to put natural gas turbines. They're extremely efficient, and they can ramp up and take the peak load. Because if you can't take the peak load, what will happen on the grid? Your voltage will drop, and all your computers will get burned up. All your refrigerators get burned up. You have to have a balance on the grid. So just...
This is also one of the open docket numbers with the PUC. They're looking, it's called a resource plan. How are they resourcing the energy? So if you would like to be engaged in that process, you absolutely can. The staff reports, each of the utilities is tasked with answering your question specifically. They submit that to PUC staff, and it's open for any and all of us to comment on. And I can point that out. Go to OPUC, everything's right online. So.
Shannon, I want to speak a little bit too. I'm going to go out on a limb here and say that this project is not attached to the LNG terminal coming into Coos Bay. We have other natural gas pipelines in the state of Oregon, and those power plants can be elsewhere. So not related to an LNG terminal in Coos Bay, although we can utilize natural gas in other places in Oregon with an updated grid, right? So moving forward with that, there are lots of technologies in energy storage, and the more that we put our energy into renewable energy systems, the energy storage technologies will increase rapidly, guaranteed.
Very good, thank you so much.
I'm going to add one more thing. I'm sorry I didn't clarify. And that's exactly the kind of thing that you'll see in the reports and the other stakeholders, is that the battery storage technology has developed so rapidly that even the utilities are installing considerable storage banks with their own solar generation to take care of that duck curve. So as of today, do we need those gas plants? Yes, but if we really focused, as of next year, we wouldn't.
You know, battery storage is incredible. In Europe already, they're running ferries on batteries. They're storing up Norwegian hydropower in Germany and discharging it in batteries to run ferries back to Norway. So yes, it's coming, but to run a grid like California off of batteries, it's not there yet in the foreseeable future, but it's going to be there eventually. But in the meantime, I think our countries need grids that are stable grids. And natural gas, I'm sorry, but I'm a chemical engineer and I know about the power grid in Texas, and it is the best grid in the whole world. It's the cheapest cost, and they get 2 to 3 times the efficiency out of natural gas to make power. 2 to 3 times what Oregon does in natural gas. So it's a requirement of natural gas to make products. And from the waste from the energy plants, they're used to make products in Texas. So it's not just to burn it, to make natural gas into energy. The steam that comes off the power plants of natural gas plants in Texas, they call it cogen. I don't know if you ever heard of this, but combined cycle cogen plants are the most efficient in Texas anywhere in the world. They get over 100% thermal efficiency. Oregon gets about 50% on their gas plants. So, you know, we're going to have natural gas to make products, or we won't have any industries. And you can't shut down industries. Natural gas is here. Realistically, I'm opposed to just burning it to make power. Saudi Arabia has single cycle natural gas power plants. They get 28% efficiency. The one in Oregon and Washington, they get 50%. Texas, they get 110%. So it's all in how we burn natural gas, but we have to have it for products. Our industry depends on natural gas, mostly for the products, which is oftentimes a byproduct from making electricity.
Is it correct that you will be you will have your facility and you'll be building your platforms on the North Spit?
Yes.
Okay. How will you then deal with the problems of traffic, logistics, tsunami, all of these problems that we have been looking at, that we have been facing with our ideas of a natural gas plant down there and the possible problems? You will have the same ones. How will you deal with that?
Well, the spar pole design has already been tested in hurricanes. Okay, it's not quite.
Talking about the plant on the North Spit, how will you deal with the problems logistically
to have a great number of workers down there in problems of tsunami and the dangers involved?
Well, that's a real good question, and please understand, I've got employees, I've got family that works out there on the North Spit. So we have looked at this. Our third story, our building was designed for the earthquake. It's also been designed for tsunami. Our third floor is well above the tsunami level. It's been designed structurally, stronger than probably any building in this whole county. So will we survive a tsunami? I believe we will. I think it's the safest place to be on the North Spit would be up in our building on the third floor.
I'd like to speak a little bit to that as well, Natalie. As far as tsunami danger, I mean, you know, there have been tsunamis to hit the coast of Oregon from Japan, and we're pretty well protected. Now, if we're talking about like a very large tsunami that could be produced, you know, from something more offshore, close to Oregon, the wind generators that are offshore would give us potentially a better reaction time. Is that accurate? I mean, could we talk about that? And also one more thing on that. It's not a liquid natural gas terminal that would become unstable with its coolers and then create an explosion on top of a tsunami. It would just be regular industrial materials that are already pretty much in use in the area. So I don't see, there will be environmental impacts, that's for sure, with any manufacturing. So, you know, dealing with all the different agencies and layers of agencies, I'm sure that all those environmental factors will be addressed. Otherwise, things won't be permitted properly. But I feel that this project is much more safe than other projects that could become unstable due to tsunamis.
The floating units are the safest, probably the safest generator of electricity you can have in a tsunami or earthquake of the Cascadia type. And that's why it's the only type that the developers are going to be willing to invest in. They're not going to be willing to invest in the ones that are fixed to the ocean floor, because those are very vulnerable. But the floating units, the way they're designed like a spring. They will go up to whatever. They are designed for the tsunami. You have to design it for a tsunami. They're not going to let you put it out there. The federal government's not going to let you put those things out there. So is it going to be totally safe? Well, I'm an engineer. I'm a scientist. Nothing is 100%, but you design it to do the best you can under the most realistic conditions. But as far as the Japanese tsunami, that's not going to impact our facility, the Japanese tsunami. The one we're talking about is the big one. It's the Cascadia. And I don't know if anybody is totally prepared for the Cascadia. But by the way, the natural gas, the LNG plant is designed for the Cascadia and for a tsunami. In fact, we use the engineering criteria off the LNG plant for our facility.
We all know that salmon return to their natal stream based on olfactory sensing once they get back to where they can sense the water from the stream. But the scientists have recently discovered that salmon navigate through their life cycle in the ocean based on magnetic fields. In fact, there at the research center, they have a big tank that's made out of fiberglass and wood, and they wrapped a bunch of wires around the thing, and they could adjust the magnetic field of the tank. And they put the little salmon smolt in there, and they're Oregon salmon. And you set the magnetic field to Alaska, and all the salmon will turn and point towards Oregon. Or you put the magnetic field to California, and the salmon will point north. So we know that they're programmed to navigate through the ocean by a magnetic field. What we don't know is what effect a large cable, I mean, if you have offshore, you have all the windmills out there, then you got to have a cable to bring the power ashore. And what we don't know is, will that magnetic field around that cable potentially have an effect like an electric fence stopping the salmon migration? That's something we don't know. The researchers there have discussed it and talked about it, but said it needs further study before we find ourselves in face of a disaster we weren't expecting.
With all due respect, that has been studied. In fact, it was studied extremely thoroughly for them to put the underground cable under the bay into San Francisco. They realized that the DC current has absolutely no effect on green sturgeon, salmon, or whales. That was the primary problem in Hawaii. Hawaiian would only accept a DC current. It does not provide the inductive current that what your tests were showing. DC current doesn't do that. So just, for that information, it's already been tested. It's been proven by the California standards that it doesn't affect the species, which is not just salmon, it's the green sturgeon and whales. By the way, that research paper, that's out, you can Google it, by the way.
I currently have a solar system, and I saw the second slide that you showed, and I would like to know how to adapt that with my current solar system. If something like that is available. The little wind thing that you showed on top.
Which slide were you talking about?
I guess that's my slide you're talking about. What exactly is your question then? You'd like to have a wind turbine as well as a solar panel? Yeah. Is there code on wind right now? For where do you live, in Coos Bay or North Bend, or out in the Empire area? Shannon might know more about that actually for residential wind. My system is really quite small, and there may be codes within the city limits for residential installs on those. So I'm going to hand that over to Shannon.
I'll keep this quick because it's kind of off topic here, but in order for you to have a effectively generating wind turbine, you want it to be about 30 feet higher than anything within 300 feet of you. That means that it's going to be up there a bit. In order to get that permitted, you need to demonstrate that if that turbine was to fall in any direction, you own or have easement to any of the lands that it would fall on. And there's also a public hearing process that's associated because it is a potential obstruction to the view shed. So the answer is yes, you can do it. It is generally a more complex permitting process than with solar, which is why you tend to see more of that around. But yes, you can do it, and you would have to replace your existing inverter with one that can accommodate both of those sources.
And for further information, we'll continue that discussion out in the lobby, which we have out there. Next question pertaining to wind energy, we're going to catch this one and then call it a night.
Just a quick thought on that.
So something like that wouldn't work.
Yeah. Just another thought for your consideration is that that's a growing trend to install solar panels all in the wind farms. So you use the ground for solar and you use the big towers for wind. But that's for 1,000 gigawatt type operations, not for small.
Okay, 2 quick questions, hopefully.
I would like to direct this question to Shannon. What would it take to get a new transmission line brought down in our direction and possibly a DC line rather than an AC line? Would it be Business Oregon, or would it be a big utility like PP&L? What could make that happen? And that, as I understand it, that's kind of like our Achilles heel, and that makes us not as marketable for this project.
Absolutely. If we're looking at actually grid tying this electricity to our Oregon grid, that is something that would be required. And it's a multifaceted project. You need a developer who's coming to the table, and I would think that Business Oregon and Boost and many other organizations in this area would help to support them as advocates to the Public Utility Commission during their planning processes. There is a request process. There are studies both for transmission and interconnection. The utility that you're proposing to connect with conducts that study, although we're trying to get some changes through so that they can hire an independent contractor to do that study for them. They come up with the costs that would be required of the developer to do that, which would be something that I think Dennis is suggesting the port would get in that game as one of the infrastructure developers. But these are publicly traded utilities. They are investor-owned, and they serve their investors. They don't serve us. So if we have a private developer, in this case wind, or the community even, saying that we want to tag onto the grid, they produce the study, they tell us what the infrastructure needs to look like we pay for it. In order to get that process even going, we need a lot of political pressure to make that a priority. So going back to our elected officials.
Just a word on that. I've talked to Bonneville. Anything that wants to use the corridors of Bonneville, and we would have to use the corridors of Bonneville, they will control, they will build it. You just pay them money, $1 million a mile. Hauser is an end of that. We have a couple spots to tie into the Bonneville grid. So it may be something, I don't know if it means a private, like Backcore or somebody, to get it from the shore to Hauser, which is the nearest point contact for the Bonneville grid. But Bonneville will take care of that. He says it just costs you $1 million a mile, and you don't have any control of that. We engineer it, we build it, and you just pay for it.
Hello, my name is Alan Whitney, and I've got several questions. But first one is, what happened to the wind farm that was down on Whiskey Run? It was done about 25 years ago and was taken down. It was an experimental farm, and why wasn't, most of the time that wasn't even running. Number two was the wave action generation that was being researched, I believe, up near Newport, if I remember correctly, and what's the status of that in addition? And number three, will Portland even let us develop anything down here? With Governor Brown, everything goes to Portland.
I'll respond to the first two. I can't respond for Governor Brown. The wave energy project, we've been involved in that. We bid on the one going to Hawaii, and I can only quote a top professor from one of the major universities and says wave energy is just a big boondoggle, okay? I don't think anything that's been done has worked. From a physics standpoint and math standpoint, a physics professor says it doesn't work, and I've looked at it, I don't see how it can work. Wind energy has advanced so far, it's jumped way over the top of anything about wave. And we're talking to the professors of engineering at Oregon State. We're trying to get them involved in a consortium. They are completely hooked by their wave program because they've gotten maybe $100 million for it. And so it's going to be difficult to get into their wave site off of, I think it's Newport, somewhere up there. We're trying to do that to get a demonstration unit, because there is no demonstration units in the Pacific Ocean. We need one. That may be the first thing that's going to have to happen along with the grids.
I believe your first question, that was antiquated technology. My understanding of those turbines is that they couldn't self-correct, and they were winding. And I'll hand this back in just one moment. The demonstration plots for the wave terminals are still on track to go forward. I want to say it's 2020 that Central Lincoln PUD has already developed the 40 megawatt offloading capacity just south of Newport. There is a trunk line that goes out to 4 stations that are designed, each of them, to accommodate 10 megawatts. 10 megawatt is a good scale design. Right now, what we have is over 1,000 wave energy technology hypothesis projects at NREL, and then we take them to the Wave Lab up at OSU and work them out at a smaller scale. This will be a significant investment in determining the validity of Dennis's statement, and I believe that there are many who do still believe in wave energy, and there will hopefully be a facility in 2 years that we can start to test out at full scale at 10 megawatts each, what that capacity is. I believe that there may be some potential, though, for us to look at that infrastructure as a potential tether for a demonstration of offshore wind.
It's just not successful anywhere. So as far as the whiskey run, just drive down to California and go over there to Palm Springs or go down to Livermore and look up on the hills, and you'll see all these turbines. There's no blades on them. Some of them don't even have a turbine on them anymore. They're all the 300 kilowatt units of the old generation with the gearbox. The gearboxes don't work. There's too much stress on the gearboxes. So that's a throwback to when the ones were built in California. They're going to have to be replaced. You go down there, you'll see that a lot of them, they're not working anymore.
So I'd like to thank the 5 panelists who spoke this evening, and I again would like to clarify, we know the port wasn't invited. There are so many people that you all know that could have been part of this conversation. Their absence is not a
And I'd like to apologize if there was any miscommunication, but
I just wanted to clarify that because I don't want to throw Thank you all, and enjoy the rest.